Today's topic, implicit differentiation. You can see the title up there in kind of the middle. The problem we're going to be doing to start is the one over on the left, where I'm asking you to find the slope of the tangent line on the unit circle at the point 1/2 comma root 3 over 2. So you kind of see the picture there that we've drawn. We've discussed it a little bit already. And you also see then the equation of the unit circle, x squared plus y squared equals 1. So we need to do the derivative of this function right here. Okay? Before I do that, I want to show you how what implicit differentiation isn't a whole lot different than what you've already been doing. Okay? If I had this, and I asked you to find the derivative of this, okay, what would you write? So here you'd write 4x minus 4. What would you write here? Y prime. What else could you write? F prime of x. What else could you write? dy dx. Right? What does that dy dx really mean?
So it's doing the derivative of y with respect to x.
Doing the derivative of y with respect to x. The small change in y with respect to x. If you're doing change of y, or excuse me, change in y over change in x, aren't you essentially finding the instantaneous slope? Because what's your slope formula? y2 minus y1, the change in y, over x2 minus x1, the change in x. But this like represents a very small instantaneous slope. Okay? On this side of the equal sign, you just did the derivative of y with respect to x, right? On this side of the equal sign, what did you do? The derivative of x with respect to x, so that'd be like dx over dx, which is really just 1, so we never even write it. You guys with me on that? On this side, I differentiated the y with respect to x. On this side, I differentiated x with respect to x, but dx over dx is 1, so we never write it. Okay with that? On this side of the equal sign, I differentiated a y variable with respect to x. How do you do that? You just write dy dx. So, coming back here, if I'm going to find the derivative of this function, in order to find my instantaneous slope, I want to know, what does dy dx equal? Because once I know what dy dx is equal to, like I did over here, if I said, okay, what's the slope when x is 7, you just kind of plug it in, right? So my job is to find what dy dx is equal to. So let's do the derivative of this with respect to x. What's the derivative of x squared with respect to x? 2x. What's the derivative of y squared with respect to x?
2y.
It'll be 2y, but I need to multiply that by dy dx, because that was the derivative of y with respect to x. I differentiated a y variable with respect to x, and anytime I differentiate a y variable with respect to x, I need to put that in there. Jake?
So basically, the dy dx equals 4x minus 4. It's just like 4x minus 4 times dx over dx.
Essentially, this means, yes, times dx over dx.
Okay.
We just don't write it that way. Okay? And here, what is the derivative of a y? Really, it's 1, but we're differentiating with respect to x, so we've got to put this dy dx in there. So you were really kind of always doing implicit differentiation without even knowing it. Okay? The thing is, now our equations are going to have x's and y's put together. Anytime you do the derivative of a variable with respect to a different one, add this in there. Just multiply it by the derivative that you found. Here, yes, I could put dx but y. That just equals 1, right? Okay? And then what will this equal?
0.
0, because the derivative of 1 is 0. Okay? And 0 times anything. Okay? Now all you got to do is get dy dx by itself, and you'll have an equation. You'll have your derivative, and then you should be able to find your slope. Yes?
So would you ever do dx dy. Dx.
Not really, but you certainly could. Find out how fast x is changing with respect to y. But remember some of the story problems, you know, where you did like dA, dr, dB, dx, things like that. We'll start to do more of those basically. Okay? So I'm going to subtract 2x from both sides. Then what? Divide by 2y. So dy dx will equal negative 2x over 2y, which simply equals negative x over y. So the derivative of my unit circle was equal to negative x over y. Now, if I want to find the slope of the tangent line at that coordinate, what do you think you got to do?
Plug in x from y.
Plug in x here, plug in the y here, and you will get the slope of your tangent line at that coordinate. So in this case, dy dx will equal the opposite of x, so negative 1/2, divided by y, so root 3 over 2. Since the 2's are both on the bottom, they will cancel each other out when you multiply by the reciprocal, and you'll be left with negative 1 over root 3. If you want to get the radical out of your denominator, that's fine. In calculus, we start letting it slide a little bit, just because some of the problems get really, really ugly, so we start letting radicals stay in the bottom. So more than likely, this can be your answer. If you want to change it to negative root 3 over 3, there's nothing wrong with doing that if you want to get the radical out of the denominator. But, like we said before, this will now be the slope of your tangent line at that point. If I said, write the equation of the tangent line, could you do that?
Yeah.
Because you got your point, you got your slope, you can put it in point slope form and change it to slope intercept however you want to do it. Yes, to go.
So that's like derivative, like the negative x over y is for the unit circle, right? Only for the unit circle, right? No.
Only for this equation, right here. Yes.
Yeah, so it could be any circle, right? Because the 1 eventually goes to 0, right? And for any circle. Is the 1 eventually
Oh, I see what you're saying. For any circle.
any circle? And so, like, what was the equation for, like, the elliptic? That was...
Oh, so you'll have x minus h squared over a squared plus y minus k squared over b squared equals 1.
So, like, you can find the derivative of that, and that would be equal for all ellipses.
Yes. Okay? Yes.
Are we just basically going to do that since x squared plus y squared equals 1 for all equations with the unit circle?
For a circle, essentially, yeah, but you don't have too many circles.
So could we just like memorize negative x over y?
Yes, but you're not going to have that many circles.
Okay.
So here's another example. Find dy dx if x times y equals 3.
Sometimes be negative x over y. Well, yeah. No, I was just saying, like, the derivative of that.
Okay?
Is that x times y?
X times y equals 3. Yep. Now, initially, if I would see this problem, I would probably go ahead and get y by itself because it's going to be easy to get y by itself. I would change this to y equals 3 over x, okay, and then do the derivative that way. But I want to show you how you can use implicit as well to get your derivative. Okay? So, if I want to find the derivative of this equation, I need to find the derivative of x times y. What rule am I going to have to use to find the derivative of x times y? Product rules, because x times y is being multiplied together. Okay? So 1 d2. What's the derivative of y? 1 dy dx, right? 1 times dy dx. So there's 1 d2 plus 2. What's the derivative of 1? What's d1? What's the derivative of x? 1. Okay? And then what's the derivative of 3? So I just differentiated both sides of that equation. To differentiate the left side, I had to use the product rule. To differentiate the right side, I just had to find the derivative of 3, which is 0. Now all I need to do is get dy dx by itself. So this is really saying x times dy dx, right, plus y equals 0. Subtract y. You get negative y. Divide by x, and you get negative y over x.
Wait,
Yeah.
why did you just why didn't you like divide by 3 right away?
What?
Why did you divide by 3 right away? Why did you or divide by x right away?
Why didn't I?
Yeah.
I said I could. I said if I saw this problem that said find the derivative, I could easily get y by itself and do the derivative using a different rule. But I'm going to show you how you can also do this using implicit differentiation. Okay? Now, this is not quite as friendly this way, because now if you wanted to find the slope of the curve, wouldn't you have to know both an x and a y value of a coordinate in order to find the slope?
Yeah.
Where, had I done it the other way, I only need to know the x value of a particular coordinate to find the slope, because my derivative would be in terms only of x. Okay? Let me find one that's maybe a little bit more complicated. And borrow your book a second, Jake. Oops, sorry. Okay, so let's try this one.
Oh my gosh.
Which, by the way, just for FYI, the graph of this makes kind of a cool little sideways figure 8.
Nice.
Yeah.
Rule.
Alright. So, here we go. Left side. 6 x squared plus y squared to the first times the derivative of what's inside
Which is 2x plus y plus 2y.
plus 2y
Times
dy dx. I did the derivative of the left side. Now to do the derivative of the right side, I again have to use the product rule. Okay? You can either keep your 100 out in front of all of it, or if you want to include the 100 with the x, that would be fine too. You do it either way. I'm going to probably, just so I don't have extra parentheses, I'm going to put the 100x as my 1 and my y as my 2, thinking 1 d2 plus 2 d1. That's how I'm going to do it. If you'd like to just keep the 100 out separately, it's entirely up to you. Okay? So 1 is going to be 100x. d2 is going to be dy dx. So there's my 1d2
Plus.
plus 2 d1 would just be 100. Questions on that so far? Okay, now we need to get dy dx by itself. That's going to be a fun one. Okay?
Simple.
So here I got 100x dy dx plus 100y. That's easy. Okay? This side is not as easy. So I'm going to distribute the 6.
Then do we have to foil?
I think we're probably going to foil.
This is foil.
So 12x cubed plus 12x squared y dy dx plus 12xy squared plus 12y cubed dy dx. So I just foiled there. Just gotta be careful on your powers. Now if I'm trying to solve for dy dx, I need to do what?
Get it one time.
Get all my dy's, dx's on the one side and get all my terms that don't have dy, dx's on the other side. So personally, I'm going to move this term over here, and I'm going to move this one and this one over there. Everybody see that? Stop me before. So I'm going to keep this one right here, so that will give me 12x squared y dy dx plus 12y cubed dy dx. And if I move this one over, that would be minus 100x dy dx.
So it'd be plus, right?
Where at now?
Or no, it'd be minus, sorry.
To move this one, I would have had to subtract it, right? And on the other side, I got my 100y that was already over there. I would have had to subtract the 12x cubed to get rid of it on this side. And I would have subtracted 12xy squared. What? So I subtracted this from both sides because I only want the terms with dy dx's on the same side. So this one does not have a dy dx, so I had to subtract it from both sides. So this is gone here, and then on the other side I have a negative 12x cubed. And then this one I wanted to get rid of too. So I subtracted this from both sides. So that's why over here I have a negative 12xy squared. Better?
Yeah. Then you brought the 100.
I brought this term here. Okay. Now to solve for dy dx, I have 3 terms of dy dx in it, so I'm going to need to factor it out. Okay. Some of you will be able to write your answer at this point, which is fine, but I'm going to go ahead and show all my steps here. Okay. If I factor a dy dx out of everything, that'll give me 12x squared y plus 12y cubed minus 100x equals, I'm not going to change that side up, and then to solve,
Now you have to divide by.
I'd have to divide by that quantity, right? So I'll just get an ugly fraction.
Would it really be that big of a fraction?
So dy dx will equal this, 100y minus 12x cubed minus 12xy squared. Although I'm not reducing this. Really, I think the only thing you could do to reduce this
We get simplified numbers.
is divide everything by 4. Or 2 again. 2 and then 2 again.
Yeah.
Okay?
Yeah, that's what.
But-
yeah,
That's
let's
what I
do
was-
it. Wait, two.
Easy.
So there's your derivative.
Don't be confused about that.
If I said find the slope of the tangent line at some point, you just have to take that point and plug it in for all the x and y's you see
Yeah.
to find your slope.
No big deal. Just plug in for all that stuff.
So that's implicit.
That was long.